Sometimes when you create an object, it can be very expensive, computational expensive. So for example, when there's a lot of, when you create an object and the initialize procedure has a lot of steps, for example, setting up a network connection or multiple network connections, opening databases, opening files, and so on, then that's very computational expensive to create a new object. So what you can do instead is to create a copy of that object and just modify that a bit. That is called the prototype pattern. So it has two benefits. One is that it eliminates the overhead of initializing the object. As I just mentioned, like the initialization process or the constructor call can be very computational expensive. Another thing is that it simplifies and can optimize the use case where multiple objects of the same type will have mostly the same data. Now, the pattern itself is based on cloning a pre-configured object. So the idea is that you take an object that is configured and then clone that object and configure it to your needs. So the idea is very simple in that the object can clone itself. So in order to clone an object in Python, we use the deepcopy module, and we import copy, which will do a copy of the object. Then we can have a certain class, for example, a class car, or let's say NetworkConnector, which has a certain constructor. Then you can make an object of that network connector. However, it's computational expensive and we want another object. So it would be very expensive to do this performance-wise. So what we can do instead is to clone the object. So we can say object one, or object.clone. Now the clone method doesn't exist, so we need to create it. And a way to do that is to create the prototype class. Which has the clone method, and that returns a deep copy of itself. And so now object 2 will just be a clone of the object itself. And for this to work, of course, this needs to inherit from the prototype class so that the clone method is available in NetworkConnector. So this method will create a deep copy of the object. So whenever we call clone on an object, we just have a copy of it, and we don't have to, it will just work. So we can call the program, let's see, it just executes. And if we try to output the name of the object, you'll see that it has the same variable available as is available in the object. So it has cloned the object. And by using this, you can skip computationally expensive functionality. So for example, if this function would take a lot of time to set up the network connection, you don't want to create another object where that long process is repeated. So to be more concrete, we can add a time method here, and we'll just make this expensive. So let's say wait 5 seconds. And you'll see if you run it, it waits 5 seconds to create it. So it's now initializing, and immediately the object is copied and we can work with the same connection. However, if we were to create it manually, so if we were to say object 2 is network connector, then you'll find that not only do we have to wait 5 seconds for the first initialization of the object, but also 5 seconds again for the second initialization of the object. So you'll see that it took much longer. And that's when you can use the prototype pattern. So with the prototype pattern, you clone the object and you immediately have the object available. So it waits the first time when creating the object, but the second time we just clone the object and it's available.